All right, so we're going to talk about trapezoids today. Look at a couple different parts of trapezoids. We'll start with kind of the inside of the trapezoids and how we do with the angles on the interior, and then the sides too, a little bit. Talk about the sides and kind of put pieces together of a trapezoid. And the second thing we're going to talk about is we're going to talk about what we call the mid-segment theorem. So let's just start out with the basic trapezoid. Let's see what a trapezoid looks like, get the different parts of the trapezoid so we make sure we know and understand what those different things are. So first and foremost, a trapezoid. By definition, a trapezoid is a quadrilateral with one pair of parallel sides. And you'll notice in our drawing right here that these two sides are our parallel sides. Remember, the triangles represent those things being parallel to each other. Okay, so we've got two pieces here. We've got two pieces here. Remember, it's a quadrilateral. It has to have four sides. Two of the sides are going to be parallel to each other. So because it's a quadrilateral, the sum of all of the interior angles has to be 360 degrees. We talked about that the other day. It's the number of sides minus 2 times 180. So 4 minus 2 is 2. 2 times 180 is 360. So if I add all of these up, all of these angles up, they have to add up to 360 degrees because it's a quadrilateral. The sides that are parallel are called the bases. So we're going to call them the base. Each of them is a base. Together they're the bases. So this is a base. This is a base. Now keep in mind, base does not mean bottom. I can draw a trapezoid like this, and these are my two parallel sides. This right here and here are my bases now. So bases don't have to be bottom and top. In a trapezoid, they're the sides that are parallel to each other. Non-parallel sides are called the legs. So we'll change color here. So this is a leg, and this is a leg. Other parts of a trapezoid, the angles that share the base are called the base angles. So those two are base angles. They're angles that are formed along the base. There's another set of base angles as well. These are base angles as well. They're angles that are formed along the base, so they're considered to be base angles. These two angles aren't considered to be base angles because they're not along a base, they're along a leg. In an isosceles trapezoid, which we're going to spend a lot of time talking about, in an isosceles trapezoid, remember isosceles means two sides the same. It's kind of the same thing in a trapezoid. In an isosceles trapezoid is a trapezoid with congruent legs. So you have to have those tick marks. If you have those tick marks, obviously that means then that they are congruent to each other, and that's what's called an isosceles trapezoid. So those are the different parts of a trapezoid. Let's go with some of the different properties now that trapezoids have. In general, let's look at the properties of an isosceles trapezoid. So we just described what an isosceles trapezoid was. We said its legs are congruent to each other. And you'll notice now that the tick marks are there, showing that they're congruent. The two bases are parallel, so we know it's a trapezoid. These two pieces are called the legs. In an isosceles trapezoid, each pair of base angles is congruent. So angle C and angle D are base angles. They're a pair of base angles. Those two are congruent. And angle A and angle B are congruent to each other as well in an isosceles trapezoid. The second thing that happens in an isosceles trapezoid is if a pair, kind of the reflection of this, if a base pair of angles in a trapezoid is congruent, then the trapezoid is isosceles. It's just turning it around. If you write this one down, great. Not a big deal. It just turns the other one around. The last thing about the isosceles triangles talks about the diagonals. Now remember, a diagonal goes from one vertice to another vertice that doesn't share a side. So we've got these two vertices here, or these two diagonals here, CD and AD. And in an isosceles trapezoid, the diagonals are congruent. So meaning they're going to have the same length. So CD and AB are congruent to each other. So those are some of the things that we can put together now. Now let's look at a couple examples knowing those different things. So first, it says find the value of x and y. It's just a trapezoid. Okay, so we've got our base angles. It's not an isosceles trapezoid, so the base angles don't have to be congruent, but we do know that all of these angles together have to add up to 360 degrees. Well, this is x and this is y. Well, maybe there's another property in here that we didn't talk about, and I think there is. So if I take this side and I extend it, and I take this side and I extend it. Okay, we know those two are parallel because it's an isosceles trapezoid. Now let's just kind of ignore all of this stuff for just a second. If you notice, we've got two parallel lines here and here that are cut by a transversal. If we have two parallel lines that are cut by transversals, we had a lot of different properties to talk about when we had that. We had alternate interior angles were congruent. So those two angles are congruent and those two angles are congruent. We had alternate exterior angles were congruent. So if I, wrong little drawing here. If I extended that and I extended that, alternate exterior angles are congruent. So those two are congruent and those two are congruent. But we also had what was called same side interior angles. And we said same side interior angles, which is what these two are, those were supplementary to each other. So supplementary means that they have to add up to 180. So in a trapezoid, the two non-base angles, that pair, those are going to add up to 180 degrees. So y plus 72 has to equal 180. Subtract 72 from both sides and get y is equal to 108. Well, it also has to happen over here. X plus 106 has to be 180. Subtract 108 from both sides, 106 from both sides, and you get 74. So there's another thing to keep in mind. The angles that kind of run along the leg, those are going to be supplementary to each other because they're same side interior angles. All right, the next one. Next one says find the value of x and y. Well, it tells us that these two are congruent to each other. We're going to assume that it's a trapezoid, even though those things aren't there. So if it's an isosceles trapezoid, those tick mark means it's congruent. So 2x has to equal 10, divide, you get x is equal to 5. Now, because it's an isosceles trapezoid, we know that base angles are congruent. So those two angles have to be congruent to each other. So y is equal to 74. Those are my two solutions. The next one, if a trapezoid below is isosceles, solve for x. Now it's telling us it's isosceles, so these two are parallel. Base angles have to be congruent, so 5x has to equal 60. Divide, you get x is equal to 12. And the last one, if AD is, so AD is right here, BC is right here. If AD, so we've got diagonals, it's isosceles. So we've got this, it's a trapezoid. So in an isosceles trapezoid, the diagonals are congruent. So 9x minus 5 has to equal 5x plus 23. Subtract 5 x's, add 5, you get 4x equals 28, you get x is equal to 7. And there's your solution for those first 4 examples. Let's look at another one. Is this trapezoid below isosceles? Well, we've got those two base angles are congruent. And if the base angles are congruent, those two angles have to be, or those two sides have to be congruent. Therefore, the legs are congruent, so it's an isosceles trapezoid. And the last one. Again, we've got this isosceles trapezoid. We know that because we've got this and this. These are my two base angles, so they have to be congruent. So y is pretty easy. Y has to be 70. Well, we know those two have to be the same. So if they have to be the same, if I can find one of them, I know what the other one is. Well, I know this is 70, and these are two angles that run along the legs. So x plus 70 have to be supplementary. So you get x is equal to 110. So if x is 110, z has to be 110. So there's a few questions on interior angles and isosceles trapezoids, kind of the first part of the lesson. Second part of the lesson, we're going to talk about what's called the mid-segment theorem of a trapezoid. And by definition, the mid-segment of a trapezoid is the segment that joins the midpoint of the two legs. So here are my two legs, AC and BD. Here's the segment that we're calling the mid-segment, EF. It's halfway between A and C and halfway between B and D. So this is what we call a mid-segment. Now, a couple properties with this mid-segment. First property with that mid-segment is the mid-segment is parallel. Oops, I should probably not write with a highlighter. Is parallel to the base. So I could go ahead and put that parallel sign in there. The second part about the mid-segment, and the more important part of the mid-segment that we're going to talk about today, is the length of the mid-segment. The length of the mid-segment is half the sum of the length of the bases. So my bases, remember, in a trapezoid are the two parallel sides. So in this case, the length of the mid-segment, which is EF, that is going to equal 1/2 of the sum of the two bases. So my bases are AB and CD, and sum means to add. Now this is going to be a very important formula, and this formula is one we're going to use a lot when we're talking about finding the mid-segments in the examples below. That mid-segment, which in this case is EF, is going to be 1/2 of the sum of the other two bases. Now they may have different names, or different letters, but that's still going to hold. So if we look at our first example, number 7, it says find EF. Well, EF is my mid-segment. So my mid-segment theorem tells me, and we're going to use that mid-segment theorem, that EF has to equal 1/2 of AB plus CD. And I like to write the formula down every time because now I just use substitution. I don't know what EF is, so I'm going to put an X there. So I'm going to make that an X. That has to equal 1/2 of AB. Well, AB is 2.5 plus CD is 3. Now we just solve. That's 1/2 of 5.5, which is just 2.75. And there's our solution. And we're done. The next one, a little different question. Find CD. Well, EF is my mid-segment again, so EF is going to have to be 1/2 of AB plus my other base, which is CD. So CD is what we have to find, so I'm going to make that an X. So EF's length is now 12, AB's length is 8, and I'm just going to make CD an X there. Well, I don't like fractions, and the easiest way to get rid of fractions is to multiply both sides by the denominator of that fraction. 2 times 12 is 24. Half times 2 is 1, so I'm just left with 8 plus X. Get X is equal to 16. And there's our solution, and we're done. Now, things about geometry, and like things I always like to say about geometry, is concepts don't change. What changes in geometry is the level of algebra that you have to do. And that's what's going to happen in this next problem. But if you keep our formula in mind, that EF is equal to 1/2 of AB plus CD, and you just use substitution, it makes it not that bad. So again, our mid-segment is EF in this one. Our bases are AB and CD. I can replace EF with what I know it is. It's 5X. Our 1/2 stays the same. AB is now X plus 6. And CD is 12. Okay, I'm going to get rid of the fractions here first. So I'm going to multiply both sides by 2. So that's 10x. Now I'm going to combine that. Half of 2 times a half is just 1. And this is going to give me x plus 18. 6 plus 12 is 18. Subtract 18. Oh, sorry. Not going to subtract 18. That's probably the long way to do the question. Don't really want to do it the long way. Let's subtract x instead. So 9x equals 18. Divide by 9. You get x is equal to 2. That's what it wanted us to do. We're done. We move on to the next question. Last question is going to ask us to find a whole lot more. We still have a trapezoid. We have to find the value of x, and then a, b, and ef. Well, it's still the same thing. It's a mid-segment. So ef, which in this case is 3x, is going to equal 1/2 of AB. So that's equal to 1/2. AB is now just x plus 3 plus CD. CD is just 12. I'm going to solve just like we did the last one. Multiply both sides by 2. 2 times 3x is 6x. 2 is that. So that's just 1. So that leaves me with x plus 15. Subtract x. 5x equals 15. X is equal to 3. So I've got the first part in, but now I need to know what AB is. Well, AB is right here. AB is x plus 3. Well, I know x is 3, so 3 plus 3 is 6. So AB is equal to 6. EF is 3 times x, so 3 times 3 is 9. So EF is equal to 9. And there are my solutions. So there's trapezoids and the different pieces of a trapezoid, whether it's knowing what the bases are, whether it's knowing what the legs are, knowing where your base angles are, all of those different things within that. With an isosceles trapezoid, knowing that the base angles are congruent to each other, the legs are congruent to each other, and also keep in mind that the angles that run along the legs in any trapezoid, those are going to add up to 180 degrees. That's the first part. And the second part we talked about that mid-segment theorem. Very, very important that you always write down the formula first, and then just fill in and use substitution. That's trapezoids.